Hello, this is the first unit chapter review for geometry. We're going to go through each problem one by one, and your job is to make sure you can do the same eventually. Even if you have to go through the video several times and do several reviews, you want to be able to do this entire review by yourself with no help and get it 100%. And that way you'll know for sure you are ready for the test. So let's get started. The first part is just about naming different parts of a plane, lines, and points. So let's look at this. Another name for line M. You can see line M right here. So on that line we have 2 points, which are D and B. So we're going to call this line DB or line BD. Either way is fine. Now, in order for it to be an actual line, we got to have the arrows on top. So we're going to put this arrow on top, and line goes in both directions forever, so there's a line on both sides. You got to have both. So one or the other, not necessarily both. Okay, same thing for line L. Okay. Now we have 3 letters here, so we only need to use 2 in any order. So I'm just going to pick the simplest, which is AB. So line AB looks like this. But there are, see here, you can do AB, AC, BC, and then the reverse of any of those as well. Another name for plane P. So the whole plane is called plane P, right? And we just need to pick any 3 non-collinear points. So we can pick ABD or ABE, CEB. Any 3 non-collinear points would be acceptable here. So there are many different possible correct answers in this question. Okay, so plane A, B, E. I'm going to go with. Name a point that's not on a line L or line M. So not here and not here would leave only, looks like point E. Okay, point E. Name a pair of opposite rays. Okay, so we have, let's see here. M almost has opposite rays, but we don't have another point here to make the second ray. So we're going to have to go with line L, where they both start at point B, and we have ray BC. Got it black. We have ray BC and BA. And since they are rays, we do have to put the right notation. Rays always have the arrow pointing to the right above it. Even if in the picture the arrow is pointing to the left, kind of like it is here, we still put pointing to the right on the notation. Okay, so that's our beginning there. Let's go down to angles. So we have another name for angle 2, and we have to use 3 points. We're going to use P, R is the vertex, so it's going to be in the middle, and then Q. So we're going to say angle P, R, Q, or you can reverse it and say angle QRP. QRP. Either way, R has to be, the vertex has to be in the middle. Okay. Name the sides of angle 2. All right, so that's going off this. We can do this 2 ways since we have the angles listed, but the simpler one is probably to just look at the diagram. We have ray RP, and there's a ray because we have an endpoint, and then it's going in infinite direction on that side. So we got ray RP, and then we also have ray RQ. And we can also get that from our angles if we wanted to here. So we can see here's RQ, and then right here we have RP. So that's one ray, that's another. And it wouldn't matter which one we pick here. So we can always get the sides of an angle, the rays of an angle, from its actual angles. Here we go. All right, so let's look at angle, name the vertex of angle 2. Okay, so we're still here, so that would be angle R. All right, let's do this again, but for angle 3. So very similar. Just good practice. Here's angle 3. So we can do QRT, QRT, or TRQ. Just reverse it, TRQ. Okay. Name the sides of angle 3. Let's try it here. I can get RQ. That's a ray. Okay. And the RT. And we can confirm that from the diagram. Here's RQ, one side, and RT is the other side. And of course, the vertex is in the middle, which is angle R. Good. So that's a good review of the angles. Let's look at some of the segment length. Segment length, we looked at that and we used two methods. We use the Pythagorean theorem, which was a squared plus b squared is c squared, and then we also used the distance formula. So two ways of doing it. Now, since we have a diagram, the Pythagorean theorem is probably going to be the easier of the two. So we're going to see whether these two are the same or different lengths. Okay, so let's look at CD first. CD, we have 1, 2, 3, 4 over 1, or run of 1, I guess. And then for EF, E and F, we have a going up 2, going over 1, 2, 3. So you might be able to look at this and say for sure they're not the same length, but it does say to justify your answer. So simply saying, well, the picture kind of looks like it's not the same length is not going to be acceptable. We need to prove it mathematically. So let's do the Pythagorean theorem for each. Okay, so CD, length of CD, okay, going to be the a squared plus b squared. So we're going to do 4 squared plus 1 squared, right? And then we're going to end up taking the square root. So we have square root of 16 plus 1, which equals the square root of 17. We don't need to find out what that decimal is because we're just going to compare and see if EF happens to be the same measure, square root of 17 or not. So here we have EF. That's going to be equal to 2 squared plus 3 squared. Okay. And we have 4 plus 9, which equals square root of 13. So in this case, CD is not equal to EF. All right, let's do another. Same method. Let's see here. GH, 1, 2, 3, 4, and up 2. And then JK, 1, 2, 3, 4, over 1. And once again, we could probably look at those and say, well, they're not going to be the same length because even though they have one side that's the same, the second leg is not. But we still have to justify the answer. So let's write it out. So GH is going to be 4 squared plus 2 squared. Let's take the square root. We have 16 plus 4, which equals the square root of 20. And then we have JK, going to be 4 squared plus 1 squared, which will be the square root of 16 plus 1, which is the square root of 17. Okay, so once again, we have justified our answer that these are not the same length, so JK is not equal to GH. All right, let's look at 14. So we got to determine the coordinates of the midpoint for each segment and then identify the quadrant. So 2 parts. We're going to do 2 parts. So let's find the midpoint first. So we're going to simply take the average or the middle of each of the x values and then the same thing for the y. So we're going to find the middle of each x value by adding them and then taking half of them. All right, so 7 plus 2 over 2 will be 5 plus 2 over 2 is going to be 7 over 2, which is about 3.5 or 3.5. And then we can do the same thing with the y values. Negative 3 plus 4. We have negative 3 plus 4. Take half of it. So that will be 1 over 2, which is just 0.5. There's our midpoint. And what quadrant is this in? And by quadrant, we're really looking at the sign. So we see that this is a positive comma positive, so really fast. This is where both x and y are positive in the first quadrant. Then we can go over here, and the x is negative, but the y is still positive. That's the second quadrant. Down here in the third quadrant is where both x and y are negative. And then the fourth quadrant, the last option where the x is positive but the y is negative. That's the fourth. So this would be, both positive would be in the first quadrant. Let's do one more for midpoint. Again, we're going to add them and take half or divide by 2, same thing. So we're going to do negative 2 plus our negative 8. Divide that by 2. That's going to be negative 10 divided by 2, which is negative 5. And we'll have our 2 y values, which are 3 and then negative 2. Divide that by 2. So 3 plus negative 2 is 1. 1 divided by 2, again, is 0.5, or just half. And this time we have a negative, comma, positive. X is negative, y is positive. X is negative, y is positive. This is the second quadrant. All right, let's go down to 16. We're going to find x. So if we know that we need some additional information, let's see here. And let's say right here is going to be a length of 4. Without that, we can't really solve this equation. We need to know, solve it with 4 here. So the 2 smaller pieces, u and v, uv and cw, should add up to be our bigger piece, which is uw. Right? We have 4 plus 2x minus 13 should equal x plus 2. And let's do a little algebra. We have this 4 and negative 13 we can combine. We have 2x, and negative 13 plus 4 would be negative 9. And now we can move some variables around. Subtract x on both sides. And then we can also add 9 on both sides. This will put the variables to the left and the numbers to the right. There we go. So we have 2x minus 1x is just x. And negative 9, positive 9 cancel out. And x minus x cancel out. So we have x equals 11. And we can plug these back in just to verify if we're trying to get a high score. It's always a good idea. So we have 11 plus, let's see here, 11 plus 2 would be 13. Right? If we plug in 11 here, we'll have 22 minus 13, which should give us 9. Right? And sure enough, 4 plus 9 does equal 13. All right. Let's look at one more. About 7 QR and 6x minus 1, which is RS. Two smaller pieces should add up to the bigger segment, which is QS. We have 7 plus 6 minus 1 does equal 11x plus 1. And like the last one, we just need to combine some constants. So we have 6x plus 6, 7 minus 1 is 6. And then we can solve. I'm going to subtract 6x on both sides and subtract 1 on both sides. We have 6 minus 1, which is 5. 11x minus 6x is 5x. So divide both sides by 5, and we'll find out that x equals 1. Okay. We do need to find QS. I'll find all of them though. So if this is 1, we'll have 11 times 1 plus 1 will be 12. This is 7, so we're expecting this to be 5. So 6 times 1 minus 1 does equal 5. So 7 plus 5 does equal 12. QS will be our final answer. Okay, let's do some more of these, but with no graph given, so we have to sketch it out. So it says that A, B, and C are collinear, so they're on the same line. B is between A and C. So it's important that we have a good, accurate diagram before we begin. And so we know that A and C, and B is someplace randomly between the two. We don't know if this is an accurate diagram. B could be way over here, and AB could be very big, and BC could be very small, but we don't know yet. So we're going to have to just draw a rough diagram right now. So BC is x plus 17, and AB is also x plus 17. Okay, so it looks like this is a midpoint. Because if these are both the same, this B must be the midpoint. Okay. So then AB, or AC, there we go, is 18. So just like the problems before, we just need to add the two pieces and should add up to the big segment. Two small segments add up to the bigger segment. So we have two of these, right? Here's 1, here's 2. So I have 2 times x plus 17, and that's equal to 18. Divide both sides. Means we have x plus 17 is now equal to 9. Subtract 17 on both sides. X equals negative 8. Okay. And we were trying to find what AB is, so we can just plug it back into here. AB is going to be negative 8 plus 17, which will be 9. And of course, that would be the same case over here. And 9 plus 9 is 18. So our final answer here, and be careful, find AB. So our final answer is 9. The answer is not negative 8. Got to keep going to get that final answer. All right, let's do another one, very similar. Just draw an accurate graph. That's a little too big. Here. Okay, that'll do. We have A and C, and B is somewhere between the two. So AB we have at x plus 4, BC is x plus 9, and AC is 11. So the two smaller segments will add up to the large segment. X plus 4 plus x plus 9 should add up to 11. So I'm doing AB plus BC will be equal to AC. And just some algebra. We have 2x. We have 13. Do a little solving. Subtract 13 on both sides. If 2x equals negative 10, negative 2, and we can divide by 2, and x will equal negative 1. And if we wanted to, we could find that, let's see here. We're trying to find the length of BC as our final answer. So we want to know right here what this is. So negative 1 plus 9 will be 8. So it looks like our final answer is BC will equal 8. If we want to verify the other length, if this whole segment is 11, and this segment's 8, this other one must be equal to 3. And if you plug in negative 1 plus 4 does equal 3. Okay, let's continue. M is the midpoint of PQ. Okay, let's draw that. We know that M is the midpoint of PQ. So we know these two are equal to each other. MQ is going to be 5x plus 8, which since they're equal, so is PM. So this is also 5x plus 8. And we know PQ is equal to 6x plus 56. So we can add these up and solve, just like we did on that last one. Let's see. So I have 2 5x plus 8, so 2 times 5x plus 8 will add up to the long segment, 6x plus 56. Just an algebra problem at this point. I can do this several ways, but I'm going to go ahead and distribute. Get 10x plus 16. Now we can do some solving. Subtract 6x and subtract 16. We have 4x, 0, equals 0. 56 minus 16 would be 40, which will leave us at x equal to 10. All right, so we're almost there. We know that x equals to 10, and what are we trying to find? Find PM. So PM will be right here. Let's just substitute in 10. Let's write this out. PM will be 5 times 10 plus 8, 50 plus 8. So PM will equal 58. There we go. 21, very similar. Oh, did it again. So once again, we have M is the midpoint of PQ. And we know PM this time is 6x plus 7. And we know MQ is 9x minus 8. Right? Slightly different from the last one. Right? But we still know M is a midpoint, which means these two are equal to each other. So since these two, PM is equal to MQ, we know these measurements are as well. 6x plus 7 must be equal to 9x minus 8. So let's go ahead and solve. We'll have 15 equal to 3x, and that means 5 will be x. And we're trying to find PQ, which is this entire length here. We only know half the length. If we plug in 5 for either one of these, it should give us the same number. So let's try here. 6 times 5 plus 7 is 37. If we do the same thing here, 9 times 5 is 45, and 45 minus 8 is also 37. So this whole length will be 37 plus 37, which is 74. So PQ just comes from 2 times 37, which is 74. So there's our final answer right there. Okay, so here's some protractor problems. We'll have to come back to those. Can't do protractors yet right now. Let's do some angle addition. So very important to label all these correctly. That will give you the best chance of getting the right answer. So we're trying to find RQP. RQP. Which actually looks like a straight angle. My guess is this is going to be 180 degrees. Let's go through and verify. So we have RQF is 20, and FQP is 160. Okay, so Hunch was correct that the blue plus the pink here should add up to the red. So yes, and let's try that again. Measure of angle RQP equal to 20 plus 160, which equals 180 degrees. Let's try number 25. DEF, so this large angle here, it's going to be 167 degrees. MEF, small angle here, will be x plus 22. And then we have DEM, which will be x plus 147. All right, so our two smaller angles should add up to our large angle, which is the red. So we're going to have the pink plus the blue should equal the red. The two smaller angles will add up to the larger angle. We have x plus 147 plus x plus 22 will equal 167. So with a little algebra here, we'll have 2x plus 169 equals 167. Okay, we can subtract 169 on both sides. We'll get equals to -2. And then divide both sides by 2. X is -1. And that was the question, was to find x. So I did find x, so I am finished. But we could verify just to make sure everything adds up to 167 by substituting back in. So if this is -1, that would make this 146 degrees, and that would make this 21 degrees, and sure enough, 21 plus 146 does equal 167 degrees. All right, a little bit more here. CBM, we're trying to find. So we're trying to find this small angle. And we know angle MBA, 142 degrees. We know CBA, full angle is 40x plus 4. And CBM, okay, let's see. CBM is going to be 4x plus 6. Okay, so again, that's angle addition postulate says the red plus the blue should add up to this pink. We're going to do two smaller angles, 4x plus 6 plus 142 should equal 40x plus 4. Let's do a little algebra. So we have 4x plus 148. Right-hand side stays the same, and then we can do some solving. Subtract 4x on both sides. Subtract 4 on both sides. So we'll have 144 is equal to 36x. And when we divide both sides by 36, we get x equals, or 4 equals x. However, that is not our answer because the question was to find the blue angle right here, 4x plus 6. So our final answer will be CBM should be equal to, I guess I should say the measure of CBM should be equal to 4x plus 6, which will equal 4 times 4 plus 6, since x equals 4. So 16 plus 6, 6, and that will be 22. There's our final answer. Okay, go on to the next. Now we're drawing angles. So we've gone from segments to some angles. Now we got to draw them. So let's be very careful and draw some accurate diagrams. Let's see here. So DF bisects CDE. This could be my angle CDE. And DF bisects, which means cuts in half. So CDE, right here, sorry, CDF, there we go. CDF right here will be 2x plus 1. FDE will be 3x minus 7. And we do know these two angles are equal to each other. Right? So since angle CDF, that measurement is equal to the measure of angle FDE, that must mean that 2x plus 1 is equal to 3x minus 7. And we just need to solve. So subtract 2x and add 7. We'll have 8 is equal to x. And that was our task to find x, so we are finished. Okay, very similar. Always draw a diagram just to make sure. And so we're being told that BD bisects ABC, which means that these two angles are equal to each other. So measure of angle ABC, that's this large angle, all the way here is 76 degrees. And we know the measure of DBC is 4x plus 6. And these two are equal, so this is also 4x plus 6. So we just have two 4x plus 6's, that's going to be equal to the sum of 76. So let's divide both sides by 2. So 4x plus 6 will be equal to, let's see here off the side, 76. It's going to go in there 3 times, and we'll get 38, okay? And then we can subtract 6 on both sides. So 38 minus 6 will give us, be 32, and divide both sides by 4, and we'll get 8. And that will be our answer since x equals 8. That's what we're trying to find. Okay, down to 29. It looks like we have a straight angle. Which means we have a linear pair, which are supplementary. So we know that this whole angle, let's try that again, the whole angle should be 180 degrees. So we're just going to add these up and set them equal to 180 degrees. So we'll have 3x plus 45, 44 and 1 is 45, and then do some solving. Subtract 45 on both sides. We'll have 1 here, 35, yeah, and divide both sides by 3. So 3 into 135 should give us 445. There we go. And that was our final answer since we were being asked to find x. Okay. We could plug in 45. Substitute 45 back in here if we wanted to find out what this angle is. Okay. There's another very similar. we got a straight angle that adds up to 180, so we know that 4x plus 84 should equal 180. Okay. Subtract 84 on both sides. So we'll have 96 and divide both sides by 4. You have 24. Okay. So when we are done, it did ask to find x. Okay. ABC and CBD form a linear pair. So let's sketch that. So remember, linear pair fall on a straight angle or opposite rays. So ABC, we call this A, B, C, and CB, that makes this D. So if ABC, 5x plus 12, and CBD is 3x, and what does x equal? So we know that this is going to add up to 180 degrees. So we're going to have 5x plus 12 plus 3x is equal to 180. So the 5x and 3x, we have 8x plus 12. We're going to subtract 12 on both sides. That'll be 168. And then divide by 8 on both sides. So 8 goes into 16 twice, and once into 8. X equals 21, and that is what we're trying to find. It's just x. We could plug them in here and show that the two angles do add up to 180 if we wanted to check. All right, let's do some transformations. Next, zoom. Let's see this. Okay. So let's just identify where P prime, Q prime, and R prime are. So here's P prime at 2, 4, looks like. And Q prime is at 1, 1. And R prime is at 5, 2. Okay. So what is the rule that maps? Okay, so we want to look and see what kind of motion is going on here, what kind of transformation. So we can see P is starting here, and here's P prime. Here's where we're starting, the pre-image. Here's our image. So they all seem to be going, sliding 1, 2, 3, 4, 5, 6 to the right, and then 1 down. So my notation will be starting with x and y, it transforms or maps to 6 to the right, so x plus 6, takes each x coordinate, adds 6 to it, and then 1 down. So we're going to take each y coordinate and subtract 1 from it. Right? This is rigid. Transformation, rigid means same shape and size. Okay, that's what rigid means. So that's how we justify it. Is that triangle P prime, Q prime, R prime has same shape and size. Let's do one more. See, for D prime, E prime, F prime. So D prime, find it right there. It's going to be -1, 0. E prime is going to be -2, comma 1, 2, 3, negative 3, negative 2, comma negative 3. F prime looks like it'll be 1, comma negative 3. All right, now we need to write a rule that maps one to the other. So X comma Y is going to map to what? So let's look at this. Looking at the original compared to the let's just say the pre-image compared to the image, where we ended up. Let's see here. It looks like the original pre-image is only a height of 1, while the pre-image you can see is a height of 3. So that's a clue that if I want to look at the height or the y coordinates, you can see that they're all 3 times as large in the image, right? On the diagram here as well as with the numbers. So 0 times 3 is still 0, but negative 1 times 3 gives me negative 3 for each one of these. So I'm very confident that my y coordinates are coming from multiplying the original y by 3. And then I can tell that the x coordinates, my original pre-image is pretty wide, but my image is not as wide. And we can see that the width here is 1, 2, 3, 4, 5, 6, and we end up with 1, 2, 3, which is about half. And we can verify here to here that indeed half of negative 2 is negative 1, half of negative 4 is negative 2, and half of 2 is 1. So we're looking for patterns everywhere in the diagram and with numbers. So my new image will have size half of x. Okay, is this rigid? Does this have the same shape and size? And that would be no. Shape and size change. Okay, so this is a non-rigid transformation, also known as a dilation. Okay, let's draw some images given the pre-image. So each x will be added 4 to it. So I'm going to take a few of these x's and add 4 to them. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay. Then we're also going to subtract 5. We're going to move these each down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So it looks like my image will end up right here. And since we just added and subtracted, that is called definitely a rigid because the shape and size are the same. Okay, and this is called a translation. Okay, and it is rigid, shape and size are the same. Okay. Let's do the next. So we're going to list the coordinates here to apply this transformation. It's a little more tricky since we have a dilation here. So probably be a good idea to just write out each of the points. So we have, let's see here, 0, negative 1. We have negative 3, comma 2. And we have negative 4, comma negative 3. So for each of these, we want to double the x and add 2 to the y. So if I double the x, let's try this. Double the x, that's still going to be 0. 2 times 0 is 0. If I double negative 3, I'm going to get negative 6. If I double negative 4, I'm going to get negative 8. Okay. I'm going to add 2 to the y. So negative 1 plus 2 will give me 1. 2 plus 2 will give me 4. And 3 plus 2 will give me, negative 3 plus 2 will be negative 1. All right, looks like these numbers are a little large here, so we might have difficulty plotting this. So 0, negative 1, 0, positive 1. Okay, we're good there. Negative 6, comma 4 would be, negative 6, comma 4 might be up here somewhere. And negative 8, comma negative 1. So that's, fortunately, this is not a very good graph for this particular problem, but it would look something like this. Rigid, definitely not. We have a dilation, which is making this object a very big shape. So shape and size are not the same. Or you say different. There we go. All right, the rest are constructions which we have to use a compass for, so that will conclude for this video. All right, so your goal is to be able to do what we just did, begin and end without stopping, and get 100% using all the work and all the language found in this review. Okay, good luck. So let's go back to the construction problems from earlier and do all of those now. So first we need to go back to 22 and 23 where we are measuring angles and drawing them. So I'm going to go over to a different page here. All right, so we need to use a protractor and measure the angle and describe it as acute, right, or obtuse. So of course, acute being less than 90 degrees. Change this here. So this will be less than 90 degrees. This will be equal to 90 degrees, that's right. And then greater than 90 degrees is obtuse. So this is definitely less than a right angle, so we do have an acute angle here. Okay. And then get out your protractor. All right, now we can go ahead and measure this. You want to put this little angle right here on the vertex, and then give it a spin so that this bottom line is on one of the rays. And then we're going to go ahead and measure. And we have to know this is an acute angle, so our answer should be less than 90, which lets us know we need to use these smaller numbers down here to measure, not the big ones, because that'd be an obtuse angle. So it looks like we're right at a little bit below 70. So we can go up here and measure a little more accurately. And it looks like it's going to be about, that's 70, this is 69, this is about 68 degrees right here. And you might be off by a degree or so, but as long as it's close enough, it should be fine. So that's about 68 degrees. Okay. And then here, we need to draw a 70-degree angle, so very similar. A little smaller, there we go. Now, you saw when we measured this angle, we just had to put the protractor on a ray. So we need to create one of those first before we can create an angle. I'm going to draw it to the left here. Okay. Now again, I'm going to put my protractor right there, so right on the vertex. And then straighten it out a little bit. So the 0 is right there in the middle. And now we can go ahead and mark 70 degrees, which is right here. right there. Okay. And again, draw another ray. And there we go. Okay, let's go to the next one, which is further down. And this was, number 36 and 37. We started doing some constructions. So first we need to construct a copy of a segment and then copy an angle. So we're copying two objects. Let's start just by doing the segment and getting out our protractor. And I want to copy the length here. So I'm going to spin this around, get the same exact width here, and then just move your compass down a little bit, and then go ahead and mark. There we go. And there, oops. There we go. Now I can just draw a segment. Here. There we go. Okay, next copy this angle. So again, we need to start off with a ray. Let's see here. I think I can do it right here. Let's try that out. There we go. And get our compass out. Move it around. Put the tip right there on the vertex. I'm going to draw an arc. I'm going to copy that arc onto mine, so without changing the width. Okay, there we go. I'm going to move it over here to where my ray and arc intersect, and go ahead and adjust it. So I have the same exact width here, and make another mark with another arc, and do the same thing on mine. There we go. So you can see where this ray goes right through that intersection. I just drew an intersection of my own right here. So I'm going to have my ray going right through there. There we go. Now I've copied the angle. It doesn't have to be, you can see this is much bigger, but the angle is what I'm copying. So you can see this angle and this angle are the same, even though that one is actually, these rays appear to be longer than these ones. That's perfectly fine. And lastly, let's do an angle bisector. So we just need a compass on this one. And I'm going to draw an arc that crosses both rays. And I'm going to move my compass right here. Okay, and make it a little bit smaller, and I'm going to draw an arc like this, and I'm going to move it over here, and without changing the size, and do the same exact thing. There we go. And you can see right here where the two arcs intersect twice. That's going to be my path for my angle bisector. So then this goes right through here. And now I have created an angle bisector where these two are the same measurement. Okay, and that wraps up the constructions.